Household hairdryers are not required to have a 20 amp male cord end because their current draw does not necessitate it. A 1875 watt hairdryer typically draws approximately 15 amps. This amperage falls within the safe operating capacity of a standard 15 amp circuit, and therefore a regular 15 amp male cord end is sufficient. The 20 amp configuration, on the other hand, is generally reserved for appliances that require high power and subsequently draw more than 15 amps. Appliances such as air conditioners, refrigerators, and ovens typically fall into this category. These higher power appliances necessitate a dedicated 20 amp circuit to ensure both proper operation and safety, preventing overloads and potential hazards. Now let's delve into the specifics of electrical circuits and appliance ratings to fully understand why a 15 amp plug is adequate for a 1875 watt hairdryer. Electrical circuits are designed to deliver a specific amount of power, measured in watts, at a particular voltage. In North America, standard household voltage is typically 120 volts. The relationship between power, voltage, and current is defined by the formula power equals voltage times current, or P equals volts times amps. Rearranging this formula, we can calculate the current draw of an appliance by dividing its power rating by the voltage. In the case of a 1875 watt hairdryer operating on a 120 volt circuit, the current draw would be 1875 watts divided by 120 volts, which equals approximately 15.625 amps. This calculation confirms that the hairdryer draws around 15 amps, aligning with the typical range mentioned earlier. Electrical codes, such as the National Electrical Code, or NEC, specify the requirements for electrical installations, including the types of circuits and receptacles that are appropriate for different appliances. The NEC dictates that a 15 amp circuit should be wired with 14 American wire gauge, or AUG, copper wire, and protected by a 15 amp circuit breaker. Similarly, a 20 amp circuit should be wired with 12 AWG copper wire and protected by a 20 amp circuit breaker. These wire sizes are chosen to ensure that the wires can safely carry the anticipated current without overheating and potentially causing a fire. The circuit breaker serves as a safety device, automatically tripping and interrupting the circuit if the current exceeds the rated amperage. This prevents damage to the wiring and appliances, and reduces the risk of electrical hazards. The NEC also specifies the types of receptacles that are permitted on different circuits. A 15 amp receptacle has 2 vertical slots and a semicircular grounding hole. A 20 amp receptacle, on the other hand, has 1 vertical slot and 1 T-shaped slot, along with the grounding hole. This T-shaped slot is designed to accept both 15 amp and 20 amp plugs, while the 15 amp receptacle only accepts 15 amp plugs. This design feature helps to prevent overloading a 15 amp circuit with an appliance that draws more than 15 amps. If a hairdryer were to be equipped with a 20 amp plug, it could potentially be plugged into a 20 amp circuit, which would not pose a problem. However, it could also be plugged into a 15 amp circuit using an adapter, which could overload the circuit and potentially cause a fire. By using a 15 amp plug on the hairdryer, manufacturers ensure that it can only be plugged into a 15 amp circuit, preventing the possibility of overloading. Furthermore, the cost of manufacturing appliances with 20 amp plugs is higher than the cost of manufacturing them with 15 amp plugs. Since hairdryers do not require a 20 amp plug for safe and effective operation, manufacturers opt for the less expensive option to keep costs down. In summary, hairdryers are not required to have 20 amp plugs because they do not draw enough current to necessitate them. The use of a 15 amp plug ensures that the hairdryer can only be plugged into a 15 amp circuit, preventing the possibility of overloading and electrical hazards. This design choice is also more cost effective for manufacturers, as 15 amp plugs are less expensive to produce than 20 amp plugs. Now, to further illustrate the practical applications of these electrical principles, let's consider a few additional examples. Firstly, imagine a scenario where you have a small space heater rated at 1000 watts. Using the formula P equals volts times amps, we can calculate the current draw of this heater as 1000 watts divided by 120 volts, which equals approximately 8.33 amps. Since this current draw is well within the capacity of a 15 amp circuit, the heater can safely be plugged into a standard 15 amp receptacle. Secondly, consider a window air conditioner rated at 1500 watts. In this case, the current draw would be 1500 watts divided by 120 volts, which equals 12.5 amps. Again, this current draw is within the capacity of a 15 amp circuit, but is getting closer to the maximum limit. It is important to ensure that no other high power appliances are plugged into the same circuit as the air conditioner to avoid overloading. Thirdly, let's examine a microwave oven rated at 1200 watts. The current draw would be 1200 watts divided by 120 volts, which equals 10 amps. This current draw is also within the capacity of a 15 amp circuit, but it is still important to be mindful of other appliances that may be sharing the same circuit. In all of these examples, it is crucial to understand the power ratings of the appliances and the capacity of the electrical circuits to ensure safe and reliable operation. Overloading a circuit can lead to overheating, damage to wiring and appliances, and potentially even fires. Therefore, it is always best to err on the side of caution and avoid plugging too many high-power appliances into the same circuit. Moreover, it is important to regularly inspect electrical cords and plugs for any signs of damage or wear. Damaged cords and plugs can pose a significant electrical hazard and should be replaced immediately. Additionally, it is advisable to have a qualified electrician inspect your home's electrical system periodically to ensure that it is in good working order and meets all applicable safety codes. This is especially important in older homes, where the electrical wiring may not be up to current standards. In conclusion, understanding the basics of electrical circuits, appliance ratings, and safety codes is essential for ensuring the safe and reliable operation of electrical appliances in your home. By following these guidelines and taking appropriate precautions, you can minimize the risk of electrical hazards and protect your home and family. Now let's look at some specific sections of the National Electrical Code or NEC that relate to these concepts. NEC Section 210.21. B1 addresses the permissible loads for branch circuits. It states that a 15 amp branch circuit shall be permitted to supply lighting units, other utilization equipment, or a combination of both. The rating of any one cord and plug connected appliance shall not exceed 80% of the branch circuit rating. This means that a single appliance on a 15 amp circuit should not draw more than 12 amps. NEC Section 210.21. B2 covers the permissible loads for 20 amp branch circuits. It states that a 20 amp branch circuit shall be permitted to supply lighting units, other utilization equipment, or a combination of both. The rating of any one cord and plug connected appliance shall not exceed 80% of the branch circuit rating. This means that a single appliance on a 20 amp circuit should not draw more than 16 amps. NEC Section 210.23. A1 specifies the maximum cord and plug connected load to a receptacle. It states that where a branch circuit supplies a single receptacle, the receptacle shall have an ampere rating not less than that of the branch circuit. This means that a 15 amp receptacle must be supplied by a 15 amp circuit, and a 20 amp receptacle must be supplied by a 20 amp circuit. NEC Section 210.24 provides a summary of branch circuit requirements. It includes a table that lists the minimum size conductors, overcurrent protection, and receptacle ratings for 15 amp, 20 amp, 30 amp, 40 amp, and 50 amp branch circuits. These code sections provide detailed guidance on the proper installation and use of electrical circuits and receptacles. Following these guidelines is essential for ensuring the safety and reliability of your home's electrical system. Now let's consider the implications of using extension cords with high power appliances. Extension cords are often used to provide temporary power to appliances that are located far from a receptacle. However, it is important to use extension cords safely and appropriately to avoid electrical hazards. When using an extension cord with a high power appliance such as a hairdryer, it is crucial to ensure that the extension cord is rated for the appliance's current draw. The extension cord's gauge or AWG rating indicates its current carrying capacity. A lower gauge number indicates a thicker wire and a higher current carrying capacity. For example, a 12 AWG extension cord can carry more current than a 16 AWG extension cord. Using an extension cord that is not rated for the appliance's current draw can cause the cord to overheat and potentially start a fire. Therefore, it is always best to use a heavy-duty extension cord with high-power appliances. Additionally, it is important to avoid using multiple extension cords connected together. This can create a voltage drop, which can reduce the appliance's performance and potentially damage it. It is also important to avoid running extension cords under rugs or furniture, as this can trap heat and increase the risk of fire. When not in use, extension cords should be properly stored to prevent damage and ensure their longevity. They should be coiled neatly and stored in a dry place away from moisture and extreme temperatures. In addition to using extension cords safely, it is also important to be aware of the potential hazards of using ground fault circuit interrupters or GFCIs. GFCIs are designed to protect people from electrical shock by detecting ground faults and interrupting the circuit. They are commonly installed in bathrooms, kitchens, and other areas where there is a high risk of water exposure. GFCIs work by monitoring the current flowing through the hot and neutral wires of a circuit. If there is a difference of more than a few milliamperes between the two currents, the GFCI will trip and interrupt the circuit. This indicates that some of the current is leaking to ground, which could pose a shock hazard. While GFCIs are highly effective at preventing electrical shock, they can also be a nuisance if they trip frequently. This can be caused by faulty appliances, damaged wiring, or even moisture in the air. If a GFCI trips frequently, it is important to identify the cause and correct it. This may involve replacing a faulty appliance, repairing damaged wiring, or improving ventilation in the area. In some cases, it may be necessary to install a dedicated circuit for the appliance that is causing the GFCI to trip. Overall, understanding the principles of electrical safety and following best practices can help to prevent electrical hazards and ensure the safe and reliable operation of electrical appliances in your home. This includes using the correct types of plugs and receptacles, avoiding overloading circuits, using extension cords safely, and being aware of the potential hazards of GFCIs. Now let's talk about appliance labeling. Appliances typically have labels that provide important information about their electrical characteristics. This information includes the voltage, current, and power ratings of the appliance. The voltage rating indicates the voltage at which the appliance is designed to operate. In North America, standard household voltage is typically 120 volts. However, some appliances, such as large air conditioners and electric ranges, may require 240 volts. The current rating indicates the amount of current that the appliance will draw when operating at its rated voltage. This is typically expressed in amps. The power rating indicates the amount of power that the appliance will consume when operating at its rated voltage and current. This is typically expressed in watts. The appliance label may also include other information, such as the model number, serial number, and manufacturer's name. It is important to read the appliance label carefully before using the appliance to ensure that it is compatible with your home's electrical system. If you are unsure about any of the information on the appliance label, consult a qualified electrician. In addition to appliance labels, electrical cords and plugs also have markings that indicate their current carrying capacity. The cord's gauge or AWG rating indicates its current carrying capacity. A lower gauge number indicates a thicker wire and a higher current carrying capacity. The plug may also have a marking that indicates its amperage rating. This marking indicates the maximum amount of current that the plug can safely carry. It is important to use electrical cords and plugs that are rated for the appliance's current draw. Using an undersized cord or plug can cause the cord to overheat and potentially start a fire. Therefore, it is always best to use heavy-duty cords and plugs with high-power appliances. Another important aspect of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and preventing electrical shock. Most electrical appliances are grounded through a 3-prong plug that connects to a grounded receptacle. The grounding prong on the plug is connected to the metal chassis of the appliance. If there is a fault in the appliance that causes the metal chassis to become energized, the grounding wire will provide a path for the fault current to flow back to the electrical panel, tripping the circuit breaker. It is important to never remove the grounding prong from a plug or use an adapter that defeats the grounding function. This can create a serious shock hazard. In addition to grounding appliances, it is also important to ensure that your home's electrical system is properly grounded. This is typically accomplished by connecting the neutral wire in the electrical panel to a grounding electrode, such as a metal water pipe or a ground rod. If you are unsure about the grounding of your home's electrical system, consult a qualified electrician. Now let's consider some common electrical safety myths. One common myth is that it is safe to touch electrical wires as long as you are wearing rubber gloves or shoes. This is false. Rubber gloves and shoes can provide some insulation, but they are not foolproof. If the voltage is high enough or the insulation is damaged, you can still receive an electrical shock. Another common myth is that it is safe to work on electrical circuits as long as you turn off the power at the switch. This is also false. Turning off the power at the switch only interrupts the flow of current to the light fixture or appliance. The wires in the electrical box are still energized. To safely work on electrical circuits, you must turn off the power at the circuit breaker. A third common myth is that it is safe to use water to put out an electrical fire. This is extremely dangerous. Water is a conductor of electricity and can cause a severe electrical shock. To put out an electrical fire, you should use a fire extinguisher that is rated for electrical fires. These extinguishers typically contain carbon dioxide or dry chemical agents. Finally, let's discuss the importance of electrical inspections. Electrical inspections are an important part of ensuring the safety of your home's electrical system. A qualified electrical inspector will examine your home's wiring, electrical panel receptacles, and other electrical components to identify any potential hazards. They will also check to ensure that your electrical system is up to code. Electrical inspections are typically required when you buy or sell a home or when you make significant renovations to your home's electrical system. However, it is a good idea to have your home's electrical system inspected periodically, even if it is not required. This can help to identify potential problems before they become serious hazards. In conclusion, electrical safety is a critical aspect of home ownership. By understanding the principles of electrical safety, following best practices, and being aware of common myths, you can help to prevent electrical hazards and ensure the safe and reliable operation of electrical appliances in your home.